Welcome to Programming Concepts using Python. Today's topic, sync versus async functions. Disclaimer and today's code. So, what is synchronous and what is asynchronous? Synchronous is basically a blocking approach, meaning if you have a series of tasks, each task must be completed before the next one can start. For an asynchronous approach, each task and all tasks can be start at the same time and complete at the same time. So there is no waiting between tasks, and that is basically a basic difference between the two. Now, in these examples, we are going to demonstrate the synchronous approach first, and then we are going to demonstrate an asynchronous approach. So now this logic is basically a download logic. So I'm just gonna comment out some of the non-important code here so that we have a clear view of what it is that we are dealing with. So I have two functions. The primary one is the download, and the download has a parameter called name, which is basically the name of a file. And all it does is pause for 2 seconds and move to the next file. So every time this download method or download function is being called, it will do just that. Pause for 2 seconds, and then that's it. So first time we call file1, we pass the value file1 here, call this method, pause for 2 seconds, file2, pause for 2 seconds. So this way we are mimicking or basically reproducing a download file, which is the kind of behavior that you would have when downloading a file. So that's basically what we're doing. And then around the pause, we added a timestamp. So we just printing the file name that's been downloaded, as well as the time at the moment when the function is called, as well as when the sleep ends. So we also print this time when that name of the file, as well as the time when that ended. So that way we know how long this took, and we can validate the sleeping time. So the pause, and then we have the main function, and all the main function does is to loop through a list of files. So we have created a list in file1, file2, and file3, and then for each item in the list we called and passed the value of the value of n, which is going to be the file name. And around it we capture the start time. So this will capture the duration of all the file downloads, and then at the end of the downloads we can put the total time it's taken, the end time minus the start time in seconds. And here we are calling our main method, which then orchestrates this whole process for us. Okay, now a quick view on the diagram. So if we go right here, put that on the side here. So what's happening is we have our main Python program, which is basically all of this, and we call the main, and this is how we do that. We pass this method here, the function name, sorry, and the function name then calls the downloads file1 and pass the value of file1. That's what you can see here. And those file, that method sleep for 2 seconds, as you can see, and then the process repeat continually until the last file, and then the program ends. So in a nutshell, that's what's happening. Cool. So I'm gonna go ahead and run my code, and you can see we have first timestamp here, 18 seconds, the 18th second, and then the 20th second. That's 2 seconds later. So start file 1, done file 1, start file 2, done file 3, so on and so forth. So all of them 2 seconds apart, total 6 seconds. So like I said, that shows you that each file must complete first before the next one can begin. Cool. Now we're gonna do more or less the same, but we're gonna be using an asynchronous approach for that. So I'm gonna uncomment this part and I'm gonna clear my console. Now what I'm importing is the async IO, and async IO is a Python built-in library for writing asynchronous non-blocking code using event loop. Now think of event loop as the traffic controller. So it does not drive any car itself, and it decides who goes next based on who's waiting or finish. And also it keeps the traffic or the task moving smoothly. No one blocks the road. So, and that's what the event loop does. Cool. Now, key differences. Let's first remove the clutter, a non-important section of the code. So I'm gonna comment out anything that is not that important. So what you need to pay attention to is the async word that was added to the download function. Previously we had a function without the async word. Now our function include the keyword async, short for asynchronous. Now inside a function, we are no longer using time.sleep, rather we're using await async io.sleep 2, and 2 meaning 2 seconds. And then for our main function key changes, we are no longer using the for loop as previously, as you can see here. Now we are using the await async io dot gather, and gather basically creates the coroutines for us, which are basically functions that can run, can also yield control, and also can pick up where they stop. So you can pause them, you can do a whole lot with them. So, and that's why we're able to pass in the await async io.sleep 2 seconds that we've seen here. Now, in a simplified way, this also helps us communicate with the event control, event loop, and telling event loop that I am still busy, you can carry on with another task. And that's what's happening. So now if you look at the structure, we have await async.gather. That's a word we use. And then inside the gather, we are then passing our 3 functions here, or values. And each one of them, because we want them to run concurrently, we pass all 3 of them with file 1, file 2, file 3 download. Now, this process will then be started behind the scene together at the same time, and the event loop will then handle each one of them, because the first one will start, it will reach await, and the event loop will pick it up that this is waiting and sleeping or paused. Then it will pick up the second file which also get to await sleep and pause for 2 seconds. Pick up the third one, which is also, we also reach the await sync and pause for 2 seconds, and it will go back to see if the first the first download is completed, process them, and proceed to the second one, the third one, and so on and so forth. So now let me uncomment that first and then show you the overview of the flow using the diagram. So these are just time capture, just to calculate how long it took for the process to complete. And on our diagram, if you look at the diagram from the async approach, so our call async main, so which is our last call over here, instead of just calling main function, we then pass the keyword async.run, and then we pass in our function, which then called our async main, which then orchestrate anything and everything that we want to see running. So that function is being called, and the main coroutine begins, which is gonna be this one, async function, and the await function then start and create 3 coroutines, which are all the 3 functions, as you can see here, with our 3 functions inside, file 1, file 2, file 3. So event loop starts running all 3 tasks concurrently. So, and they all reach the point where there's a wait. That's what we mean by each task execute until first await. So it reaches that, 2 seconds, and nothing else to do. So let's just enlarge that a little bit. So it does the task, and behind the scene, it keeps on switching to see, okay, while the download number 1 is sleeping, I'll start download number 2. While download number 2 is sleeping, I'll start download number 3. And then while download number 3 is sleeping, I'll check maybe download number 1 is waking up. So if it is, it continue to repeat the same thing, and then mark all tasks finished and send the result. So that is on the nutshell what's happening. And then if we run that to demonstrate this workflow, we should see just that. So I've commented out the synchronous approach, so we're gonna run this for now. So we run that. As you can see, all 3 tasks start at the same time based on the seconds here, and they all completed at the same time 2 seconds later. So speed is of essence in this process. So if we run them side by side, what do we see? So I'm gonna clear my terminal first, and I'm gonna run my code. You can see synchronous blocking example, 6 seconds in total, and the asynchronous non-blocking example, we have exactly 2 seconds. And all download will start at the same time, and then we complete the 2 seconds same time. Now, big question is which one to use. All depends on your use case, and based on this example and demo, speed. If speed is your choice, then I would say go for the synchronous approach. If you prioritize file completion or download, no matter how long it takes, then I would say go for the synchronous approach. So I hope you've learned something new. Until next time, keep well. Bye bye.